Welcome back. In this second video we're going to look at setting up equipment profiles and user profiles, which, as I said before in the previous video, is the foundation of reliable imaging. So in the user profile manager, it's a simple case of typing in your longitude and latitude and elevation, which these days is often found on a mobile phone or even from a website which can locate you through Wi-Fi. The Sight Horizon number down here is useful later on when you're planning a target to know at what point does it cross the horizon. That's a little bit low at 30 degrees, it should be more like 40. So I'm just going to save that and update the profile. And it gives a little message at the bottom saying that's okay. That's all I'm going to do for the moment. You can obviously see that there's some greyed out things here. If I'd already connected to my telescope mount, it can import the data from the GPS sensor that was in the mount, for instance, and also there's a button here to export it. So likewise, if you have something like a Skywatcher mount, which some models have GPS, some do not, they do not typically remember their location and time data when you turn them physically off or remove the power. So sometimes that helps in things like that. So let's hit OK for the moment and look at the more important equipment profile manager. So each one of these configuration files down the left hand side is a combination of different bits of equipment that I use for imaging. So for instance, I have a number of different size telescopes, typically one mount, and I have two cameras which I use in lots of different combinations. So one of the beauties of doing it this way is that you can pull up this particular configuration, which is for Ritchie Chretton 10-inch scope with a reducer, which was using a QSI camera, and I can modify that by changing the camera and then save it as the QHY version. So you don't have to necessarily enter all the data every single time you create a configuration. In here we're going to go through each tab in turn. So here's the camera choice, depending whether you've got an ASCOM camera or sometimes SGP has built-in camera drivers as well. You can tell it to cool up and warm down at the beginning of a sequence, depending on what type of camera it is. It's wise not to do that too rapidly, because not only do you give the camera thermal shock, but also you can create condensation on the surface of the sensor if you drag down its temperature too quickly. So I typically do half an hour to 45 minutes. And in that time, while you can't image, you can do other things with the camera, like check the focusing and so forth. So these parameters down here help later on with setting up the camera and the pointing system. So the imaging scale, which is in pixels, or arc seconds per pixel I should say, with no binning, is a useful parameter that it's used as a starting point for working out plate solving. We'll discuss plate solving if you're not familiar with it later on. The readout noise in electrons, while that's not necessarily for taking an image, it can be used in Sequence Generator Pro's estimation of best exposure time, which is found on the Image Statistics tab. The pixel count, width and height, is also useful. It's stored in the file size in the FITS header of the image, and it can be useful later on. On the right hand side you have download times and gains. Again, you don't necessarily have to set it. There isn't necessarily a setting for every camera, but in the case of these cameras, when they're physically connected, you can actually set a gain for 1x1 and 2x2 and 3x3 binning, and also the electrons per ADU if you know it. Sometimes useful, sometimes stored just in the image and nothing else. Down the bottom here, the download times in seconds. Again, not essential, but when SGP tries to calculate how long a sequence is going to take, it will take the download times into account, especially if you're doing lots of short exposures. On the filter tab, you have a filter wheel or no filter wheel if you don't have any at all, and the change delay between after the filter's settled. You can also set up the filters. So for instance, if I click on here, these are the filters loaded in the filter wheel. I have the exposure time that I will typically use for an autofocus exposure with each of these filters. So these are all basically clear filters, these top two and these bottom two. This one here is a dual narrowband filter. So to be honest, that exposure time is a little short and it should probably be something more like 8 seconds. The other thing I can do is set a focus point. This is the count of the motor which drives the focuser. You don't have to put them in, but if you do know that the precise focus points with the focus motor taken in short succession after one another at a similar temperature, it's useful to plug these in, because later on what you can do is you can flip between filters, and without having to run the autofocus routine again, what SGP will do is it will just simply notice the difference between the focus points in each case and just move the focuser by that amount, because this offset between each of the filters is a constant. With one particular telescope, it'll be different on a different telescope. So for instance, while the filters themselves will introduce a difference in the focus position, some telescopes have a different focus position at different wavelengths, as well as having just the filter glass thickness typically as being different. So although filters allegedly are parfocal, they're often are not, and in this case these are all from different manufacturers and all very different thicknesses and cause quite a big deviation in focus. The other thing here on this right hand side is about flats, and you can, if you have an automatic flat system in your observatory, you can set up the flat exposure time for that particular filter. I don't do it that way, but that is an option. So let's hit OK for the moment. The other thing you can do is look at the focusing setting. So here you've got a range of different focus motors. Also you have a number of hubs and simulators. One thing to mention about simulators, ASCOM provides simulators for all the major bits of equipment, and it's quite useful to use those to get used to using SGP in the first place, and then you can use real equipment. That's especially true when you're trying to work out about telescopes and observatory roofs and things like that. Again, you've got settings that come up, it tells you which COM port it is and what when it's connected it comes up with its current position and where its limits are, etc. The other thing you can do is set a fine and a coarse focus step size, which is used in the focus tab over here. Now, where it gets interesting are these settings down here. As a telescope warms up and cools down, the actual focus point shifts, and it can be quite dramatic depending on the telescope. So you can either set yourself a reminder that says, remind me when, after X number of frames, let's say every 20 frames, remind me to refocus, or after a certain number of degrees ambient change, or after a period of time, or it sits there and waits for you to focus when you change a filter. So those are different options which are done manually, so you manually physically either focus it using your hand or with a motor. The other alternative, which I tend to use because I have a weather sensor, is I use autofocus. So very similar set of conditions plus a few more. So again, the ones down the left hand side are very similar. These are the trigger points for an autofocus run based on temperature, time, number of exposures, and on the right hand side is how it does the autofocus. So for instance, if I have a one-shot camera, which this QHY camera is, it'll take an autofocus exposure of 6 seconds with no binning. It will take 9 data points, 30 steps apart, and once it's completed, it'll take 7 seconds for the dialog box to disappear, and it has a minimum star diameter. So for instance, it doesn't want to necessarily confuse a hot pixel with a star, which can confuse the autofocus algorithm. I don't have many hot pixels on this camera, so I'm going to drop this down to 3, and we'll use that in going forward. There's something called Smart Focus. It's a good idea to have this enabled if you're using a refractor. If you have a centrally obstructed scope, the general rule is don't use it, because what this does is, if you're not quite in the right focus range, the autofocus will either back up and try a different range, or carry on going until it finds the focus going out of focus rather than just getting improving. And so it's not quite as intelligent as if you're coming from Focus Max, which can work out where you are in the focus range, but it's a very good second. The other thing you can do is determine which filter is used for the autofocus routine. So for instance, if I was using coloured filters, red, green, blue and narrowband filters, which take quite a long time to get enough light through to do an autofocus exposure, I will typically click this option, I will use a clear filter, and then what I'll do is tell it to move the focuser automatically when I change the filter rather than redoing the autofocus run. But in this case, I don't want to use one filter to do autofocus. I'll just use the filter that's currently in the light path, and I don't want to do the star size calculation all the way to the corners of the image where there's a bit of fall off, so I'll typically crop automatically my images by 20% around the margins, and that speeds up the focusing a little bit and also only tries to focus the stars that are round and haven't got any coma on or curvature. You can optionally have dark subtraction as well. You can have a library of images you took with the camera. I don't actually use that, so I can disable that, and that's probably about where I want to be. So the telescope I'm using is very sensitive, so 0.6 degrees is about right, and on a filter change. So I can hit OK, and what I'm going to do is hit save, which will update the user profile. So those changes I've made are now permanently recorded, and when I create a new sequence using this profile, it'll adopt those settings. Moving on, you've got auto adjust focus per filter. I haven't yet determined the precise relative focus positions on this particular camera and filter wheel, so at the moment I'm not using that. I'll just simply do an AF run every time I change the filter. And if you're into temperature compensation, which is not my preference, you can click on this button. If you've already determined that every degree needs 15 steps, you can type 15 steps in there, and it'll automatically move the focuser backwards and forwards on that compensation. You also need to work out whether it's going in or out. While you may think that cooling a telescope down shrinks the telescope tube and therefore you need to move the focuser out, at the same time the optics are changing, and I've found sometimes the opposite is true, that I actually need to move the focuser in as the telescope cools down, contrary to what you'd expect. The other thing you can do down the bottom here is there's a frame of focus tab. There's a default setting for the tab, but you can override that at any time. And also in regard to frame of focus, if I hop back to the camera tab, there's a little button down here called Use High-Speed Download. This applies to non-essential imaging. So on one of my cameras it takes almost 20 seconds to download an image, but only a few seconds to download if I'm using high speed. The image is a bit noisier, but that's still good enough for plate solving and autofocus. So if I just move on now to the telescope tab, this is where you'd put in your mount. So you've got a number of different mounts. You've got the hubs, you've got simulators, and in my case I'm using an ASCOM driver for the SkyX. And I can tell it to do a number of different things. I can park the telescope when the sequence completes. So in my case, the park position for my telescope is very low profile, which allows the roof to open and close without hitting it. I can also stop tracking when the sequence completes, which if you've parked it is normally redundant because the park position turns tracking off at the same time. You can allow external control of the telescope. So I leave this enabled because little applications like Sky Safari on my iPhone pick up very useful data about satellites and comets, and I can slew to that position just using the iPhone, and this allows that to happen. And then meridian flips. Now there's going to be a separate video just on meridian flips. So although the SkyX can execute a meridian flip, it will not do it automatically. It will just keep on tracking round until it hits the end stops. but you can tell it in SGP to, at a certain point in time, which is 20 minutes past the meridian in this case, to wait for that point and then flip. And then what it's going to do is auto-center after the flip. Now typically, when you meridian flip a telescope, both the RA and deck axis are flopped over by 180 degrees, and you don't point to exactly the same part of the sky. There's all the errors of flexure and cone angle and all those good things conspire, and often you're a couple of hundred pixels out. And the auto center here will take an image and work out where you're physically pointing, where you want to point, and then do a small corrective slew so that you can actually carry on imaging exactly in the same center as when you were just before the flip. So that's a good feature, and it's well executed, but we'll look at that in more detail in a separate video. Then there's a number of other things about how you sync the telescope. So some telescopes use the sync command through ASCOM to tell it that they have a slight pointing error, and then they use that error in all subsequent slews so that they're correct. Not all telescopes respond very well to that. So SGP offers a number of alternatives, including sending a sync command through ASCOM, or just locally having an offset that it uses. So the SkyX, because I have a pointing model that uses sync commands, I don't want to corrupt that model. I don't use the sync command, I just use target offset. And that will work on any telescope and is a safe option. I have a couple of seconds mount settling time, and the focal length is written down here. Again, it's used sometimes for working out plate solving and so forth, and also is stored in the FITS header of each image, so you know what your focal length is, and it tells me what the aperture is in meters. So just watch out that that's in millimeters and that's in meters. And for those telescopes that allow it, you can have a nudge so that you can just move the telescope by a fixed distance and so forth. I don't use that typically because I find the centering is more useful. The last three tabs are getting more specialized. The plate solve tab, I need to explain what plate solving is. Plate solving is a technique which takes an image and looks at the stars in that image, and it correlates it to a catalogue of stars. And it's very clever, and it will work out the orientation, the scale, and the position in the sky of the image that you've taken. Now, if it already knows roughly where you are, it may take only 10 seconds. If you don't give it any information at all about where you are, it can take a couple of minutes. Now, there are a number of different plate solving applications. Sequence Generator Pro doesn't have one built in, but it references a number of ones that are free, which include PlateSolve2, Astrometry.net and ASTAP. Pinpoint is a paid application. I'm using ASTAP at the moment, which seems to be very good. And in each case, there are a number of settings. So for instance, in Pinpoint, if I hit Settings, it wants to know where the catalogue is. If I hit PlateSolve2, it similarly wants to know where the catalogues are. So for instance, if I do File, Configure Catalogue Directories, it already says it knows where the directories are that are okay. And in this case, it has two different directories that you can use. So just close that down. And the last one, which is quite interesting, is Astrometry.net. So this started life as a web-based program where you upload an image and then the browser comes down and gives you a response. Now, it may not be possible to use the internet, say for instance if you're in the middle of a dark field site, in the middle of nowhere. So there is a number of different settings here, and you can either have the remote setting, which uses the internet, or you can do a local setting. And the local setting, to use that, you run a particular program which downloads the relevant catalogues that's stored locally on your hard drive, and it uses that rather than the website. And as a result, it's actually quicker as well, because there's no upload and download time, and the access is a bit faster. And what that does is it allows you to if you either use it all the time, or if you have one of the other plate solvers that fails because it's too far away from the guess, this will do what they call an all-sky solve, and it will find it almost certainly, but take a bit of time to do it. And I'm using the exposure for plate solving. It doesn't have to be ultra precise to a pixel, so I'm using 2x2 binning and an 8-second exposure that speeds things up. And what here, these are the settling criteria. So it will try twice to center up. It will keep on going until it gets to 20 pixels or less error, and a rotator error of less than 2 degrees. Again, you can define which filters used. So if I'm using lots of coloured filters, I'll typically use the fastest filter, which is the clear filter for these exposures. And again, I mentioned the blind solve, which is the all sky, and here are the settings here, which is again telling you it's going to use astrometry.net for that. So you can use a combination of ASTAP here, ASTAP here, and astrometry.net here, which is a catch-all. So moving on to auto-guiding. Again, SGP doesn't auto-guide itself, but it relies on external applications that it links dynamically to. There are a number of free applications. I'm using PhD2, which is a very common one, but if you're using a video camera, a lot of people prefer MetaGuide. And you can also do a couple of things where if you want to dither your mount, which is typically done through the AutoGuider interface, but you don't want to use auto-guiding, you choose Direct Mount Guider. This isn't a physical piece of hardware or software, but it does allow a dither command to be sent to the telescope mount to move it between exposures. But you notice that when you do, some of these options down here are greyed out because there's no physical option to change a piece of hardware through the guiding process. So if I go back to PhD2, these get re-enabled. Looking down these options, you can stop the auto-guider when the sequence completes, which makes sense. You can pause guiding during autofocus, which also makes sense because sometimes when you move the focus position, it slews the star around because the focus mechanism isn't great. Settling auto-guider before autofocus frames, because I'm not doing that, I don't need that one. Pausing the guiding during image download makes sense, it reduces the USB traffic. And during backlash compensation equally makes sense because it doesn't help. And this one here is quite interesting. Restart the current frame, the guided distance is greater than 4 pixels. This is a very useful technique that especially when you're not around, if for instance something went wrong and the star went behind a small cloud or something, and the guider went haywire, it would carry on doing the exposure under normal circumstances. So it could be a 20-minute exposure that 30 seconds in gets ruined. But what this does, that says, well, hang on guys, if the guider distance suddenly flips up by 4 pixels, something's got to be wrong. And what it will do is it will restart the exposure. It will stop the exposure and restart it so that it wastes the least amount of time. You can also do something down here, which is to recalibrate the AutoGuider when the target changes. So Sequence Generator Pro, if it notices that there's no calibration in PhD2, it will initiate a calibration. But it's not something that I like to do. I like to do the calibration independently and then store it permanently within the guider because I've got a permanent setup. There are other opinions about this. Some people like to calibrate the AutoGuider each time they move to a different target, but technically speaking you don't need to do that if the whole system is rigid and secure. In the last tab, called Other, are a number of other miscellaneous bits of equipment. So if you have some kind of mechanism for taking flats with either a flap over illuminated panel or whatever, there are a number of different systems here that it will work with. The other thing you can do is change the exposures for each filter using the flat box, and that adjusts for the different sensitivities of the light and the amount of light output in different wavelengths. For instance, cold light sources don't give out much red or deep red colour, whereas a tungsten light bulb gives out lots of red colours. The other thing you can do is you can prompt to put something over the top of it. So if you haven't got an automatic system, you can manually put a system over the end of your telescope. The rotation system here, this rotates the camera. So they're quite expensive, but you have precision rotators that normally insert between the field flattener and the camera if you have space. With observatory systems, this is the roof system. So you either have either rotating roof or roll-off roof are the main options, and there are a bunch of slave settings. These are quite carefully done. So I slave to my sequence so that when my sequence starts, it first of all opens the roof and then unparks the mount, which is the order I want it to do it in, otherwise they will collide, and vice versa. When the mount is parked, it closes the roof, but the mount is parked first. So this is meant to prevent collisions. However, SGP can only go on what it's being told, and things like the SkyX can have multiple park positions, and they're programmable. So if you haven't programmed in a safe park position for the roof to close without colliding, this cannot know that. So it's up to you to check that your system is parking safely before implementing this. I have noticed that updating the SkyX sometimes removes your programmed park position, and it changes the park position, and so you can be caught out. So that's to do with the observatory. Lastly is the safety and the environment sensors. Slightly different flavours of the same thing. So I'm using a special weather sensor to detect rain and heavy cloud, and that is based on the safety sensor. And there's two, there's OK to image and OK to open. So I typically run my roof on OK to open separately in another system, and SGP will only start up when it's OK to image. And the cloud settings and the wet settings are different in each case. And lastly, I have an environmental sensor which does humidity, temperature and pressure, and that I'm using one of the little Astro stick stations from the late that he did just before he died. So they're quite useful, and they're just like a little USB memory stick, but they measure parameters. And there's a whole bunch of others. So these are ASCOM drivers, but there's a whole bunch of others which have now taken over. And there's some Hungarian ones which are apparently very good. There is support for Temperhum down the bottom, which are very cheap Chinese ones. A lot of people have problems with this, including myself, in that they keep on changing the models without any external indicator. So when they change the models, they no longer work. So they're cheap and cheerful and may or may not work. So I have several in the drawer, none of which work. So I leave these behind and I use this one. So I'm now going to save that sequence to remind myself what I'm doing, and in the next video we're going to look at the sequencer window and setting up a sequence before running it. So I'm hoping that you enjoyed this. It's covered quite a wide range of things, and there will be a little bit more about equipment configuration in the sequencer video as well, because sometimes you change things on the fly. You can't necessarily predict all the settings just sitting at a computer. Sometimes you need to witness what's going on and just change things a little. So thanks for watching, and I'll see you hopefully in video 3.